Hello, welcome to another class with Mathema. My name is Mr. Legend, and you know I'm always here to assist you with all your inquisitiveness in mathematics. Today we are starting a new topic, and the topic is indices. You must have been hearing about indices, but I want to assure you that indices is one of the simple topics in mathematics that is very important to your knowledge and to you passing your exam. Hardly will you see in a year that WAEC or JAMB or every other relative examination body will not cite questions in the area of indices for students to solve. So today, I want you to pay a very good attention to this class and to get it right when it comes to questions on indices. What is the meaning of indices? I have helped you with some analysis here. The singular word is called index. So in other words, index is the singular for indices. Indices is plural, while index is just singular. And I want us to define this with the singular word index. An index is simply the power or exponents of a number or variable. In other words, the word index means the same thing with the word exponent and means the same thing with the word power. I know you may be familiar with this word power. So whenever you hear the word power, we are talking about index and we are talking about what? Exponents. When it is more than one, you have powers, exponents, and you have what? Indices. So let's check some example here. In 2 raised to power 4, 4 here is the index or power or exponents of 2. What is the power of 2 here? 4. What is the exponent of 2 here? 4. What is the index of 2 here? 4. Indices is very important for us to break down numbers in mathematics. Numbers that may appear big, we can easily write them in their index form. For example, when you have 16, 16 is such a big number. So we can rather write 16 as 2 raised to power 4, which means 2 times 2 times 2 times 2. 2 multiplied by itself in 4 times. 2 times 2, 4, times 2, 8, times 2, 16. We can do the same thing for 27. 27 can be written as 3 raised to power 3, which is what? 3 times 3 times 3. And so many numbers like that can be written this way. 3 times 3 will give us 9. 9 times 3 will give us what? 27. So anytime you see power, it means that you split it down in the number of the power. You split the base number down in the number of the power and you join it with multiplication sign. And it will give you back the big number that we are splitting into index form. In indices, you have such an advantage because we have some laws that can actually guide you. And those laws are such that should become part of you. Although we have a way of proving them to show you that these are not just gibberish, these are proven laws from the knowledge of mathematics. Let's first scan through the laws and then we may try to exercise the proving with some basic questions. The first one, in no order anyway, but the first one I have here says x raised to power a multiplied by x raised to power b. So this becomes, because they are of the same base, I have the same base, which is x. I choose x, and then the multiplication sign become addition. So I had the power a plus b. Okay. In the same way, if I have division separating such an index number that have the same base, I can also choose the base number x. A division will become minus, and then I have b. When I have the base number, a variable, raised to power minus 1, the minus here becomes 1 over and then I have x raised power 1, and we know that x raised power 1 is what? X. So in other words, x raised power minus 1 is 1 over x. Here also, I have x raised power minus a. The minus, like I said here, becomes 1 over. So it will remain a and x. That's x raised power a. Also here, I have x raised power 1 over a. A will become the root of x. A will become the root of x. And then I have what? A, 8th root of what? X. Or 8th degree root of what? X. So here also, I have x raised power b over a. A, like we have here, we already know that the denominator will become the root. And then in this case now, the numerator will become what? The power. Also here, it's just like saying that what? This 1 also become the power, and then because anything raised power of 1 will give me the same thing, I have what? 8 roots x. So that is why I didn't put this one. So here you can translate it. 1 is the numerator here, but b is the numerator here. That's why I have what? Raised to power of b. And we have x raised to power 0 equals to 1. Anything raised to power of 0 is always 1. 1000 raised to power of 0 will give you 1. 500 raised to power of 0 will give you 1. Anything raised to power of 0 will give you 1. So before we go into solving questions and the examples in indices, you may be looking at what I have on the board. Let's just quickly play around some questions that will show us that what we have here is absolutely correct. You can always go back and forth to show that you have what? This good knowledge in indices. For example, let's translate number 1 into number. This law that we have here, let's say, is giving us a 2 raised to power of 2 times 2 raised to power of 3. This law is telling us that what? Because the base number is the same, I'm going to have 2, and because it's multiplication, it will change to plus, and then this will give me what? 2 raised to the power of 5. What is 2 raised to the power of 5? If it's not such a big number, you may write it. That's 2 times 2 in 5 places. That will give me 32. I hope you can do that. That will be 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16. 16 times 2 will give me 32. What if I want to do this not in index form? Let's do it the way we understand in mathematics. The way you understand in mathematics will definitely be that, or 2 raised to the power of 2, you will say 2 times 2, okay? And what? 2 raised to the power of 3, that will be 2 times 2 times 2. How many 2? 1, 2, 3, 4, 5. That will give me 2 raised to the power of 5. You can see that if we do it with direct knowledge of mathematics, definitely we are still going to have what? 2 raised to the power 5 that we have here. So, in other words, the shortcut to it is that just take the power. You had it when you have multiplication, rather than for you to write all this. You can imagine if I have what? 2 raised to the power of 7, okay, times 2 raised to the power of 8. Will I have to be writing 2 7 times and writing what? 2 8 times before I know that it will give me 2 raised to the power 15? No, I can just follow the law of indices. 2 raised to the power 7 plus 8, it will give me what? 2 raised to the power 15. Rather than for me to first spread out 2 times 2 in 7 places, or 2 times 2 in what? 8 places, I will now count it the way I counted here and say 2 raised to the power what? 15. So that is why this law is very, very important. So that's for the first one that we have. Now for the second one, which I have 2, okay, raised to the power 3 divided by 2 raised to the power of what? 2. So it's the same thing like this one. The only thing is that I'm going to have 2 raised to the power 3, okay. This division will change to minus 2, and that will be what? 2 raised to the power of 1, and that will give me what? 2. So if you don't want to go this way, this is what indices tells us. Let us see if we can use basic mathematics to also prove this. I can say 2 divided raised to the power 3 divided by 2 raised to the power 2 will give me something like this. 2 raised to the power of 3, and what? Division sign will give me this slash, and 2 raised to the power of 2 will give me this. And then I can spread this out 2 times 2 times 2 in 3 places, and then I will have 2 times 2 in two places. 2 cancel out 2, 2 cancel out 2. The rest I have here is 1, 1. This is 1, 1. And then I'll say 1 times 2 will give me 2. 1 times 1 will give me 1. 2 divided by 1 will give me 2. You can see we arrive at the same answer. But instead of me to go this way, you can see this look long, because when you will appreciate indices, that if the number is now big, or if the index number is such a very big one, you may be having issues. So you directly say, rather than spreading it out like this, that what 2 raised power 3 minus 2 will just give you what 2 raised power 1, and that is what 2. So that's easier to do. So for the third one, I have x raised power of minus 1. So what if this is if I put it as 4, okay? In mathematics, we call it inverse. Okay, anytime you see something like this, it means inverse. Okay, that's raised power maybe minus 1. It's called inverse, or we say reciprocal of. So what is the reciprocal of 4? Reciprocal of 4 will always give you 1 over 4. Or inverse of 4 will always be 1 over 4. So that's what it actually what means. That does not have we don't have to do much talking in that. And then we know that if it's actually 4 raised power minus 2, definitely it means that I have 4 raised to power 2. It becomes 4 raised to power 2, okay, multiplied by what? Minus 1. So that if I do 2 times minus 1, it will give me minus 2. 2 times minus 1 will give minus 2. So this one becomes like this. So this will definitely become okay, reciprocal. Minus 1 now, it means minus 1, that's 4 square raised power minus 1. So I'm saying reciprocal of 4 raised power 2 now, or inverse of 4 raised power 2. So this minus 1 now that has come out now will now become 1 over 4 raised power 2, which is what we have here. Okay, so it will become like that. So instead of you to go through this step, you just say minus become 1 over, and then your 4 will be what? Raised to what? To the power of 2. So for the fifth law that we have, okay, we have x raised to power 1 over a. So let me say 4 raised to power 1 over 2. Okay, if I want to rewrite this, I can easily say that according to the law of indices, it's going to be square root of what? 4. This 2 will come the square root, you know. That means that that 2 will be here. Of course, you know, if it's 2 that is outside, you don't need to write it. It's 2 actually out here means square root. So if it's 2, you don't need to write it. Except if the degree of the root is more than 2. Let's say you have cube root, which is 3, or fourth degree of root, which is a 4. But for the sake of this proving, no problem. Let's just put it that what our 2 is there. When we advance, we will not put there again. And then I have what raised power of what? 1, according to what I put here. And then what is the square root of 4? The square root of 4 is actually 2. That's the power here is 1. So the answer will give me 2. Okay, so the meaning of square root here simply means, since we have 2 here, find a single number that if you multiply it 2 times, it will give you 4. What is that number that when you multiply it 2 times, it will give you 4? 2 is the number that when you multiply it 2 times, it will give you 4, because 2 times 2 will give you 4. So 2 is the number that when you multiply it 2 times, it will give you 4. So that is why square root of 4 will always be what? Is actually what? 2. Although in the advanced mathematics, you'll be hearing something like plus or minus 2, but for this knowledge, it's actually what? 2. And then I can say the sixth one, what if I now have 4 raised power 3 over 2? It's just the same thing. My 2 will become what? The root of the 4, according to, okay, let me show us what if we are not doing this in the line of indices. Yes, I remember. The purpose of this is just to validate all the laws. So what if we don't want to do like that? 4 raised to power 1 over 2, okay, this 4 here can be written as 2 raised to power 2 on its own. Then I will say raised to power of half. So I will now have 2. This power 2 times half will give me 2 times half. Okay, which is over 1. 2 will cancel what? These 2. 1 will cancel 1. And the answer will be what? 2 raised to power 1. It will be 2. You can see without using what? The indices law, 4 raised to power half will still give me what? 2. So this is 2 times half. 2 times half, that's 2 divided by 2. That will give me 1. And that is what? 2. So even without the law, you always arrive at such what? An answer. Let me clean here. Okay, to show you the I think the last one, that's number 6. We don't have much to say about what? The 7th one. So we have a 4 raised to power 3 over 2. Let's use this. That will be the square root of 4 raised to power of 3. And that will give me what? Square root of 4 will give me 2. Then power of 3. And that will give me what? 2 times 2 times 2. That will give me 8. So what if I don't want to use what? Indices to actually do this? I can say 4 3 over 2, just like I did here, will give me 4 can be written as 2 raised to power 2, and then I'll put the power that is there before, and then I can say 2 raised to power 2 equals to 2 times 3 over 2. Put this over 1. 2 cancel what? 2. So the remaining thing here will be 2 raised to power 3 over 1, because 1 times 1, that will be here 1. 1 times 3 here will be 3, and that will be what? 2 raised to power 3, and 2 raised to power 3 is what? 8. So you can see that. So the last one is that anything, variable or number raised to power of 0, will always give you 1. Okay? Anything raised to the power of 0 will always give you 1. Because if you have x raised to power 1, we say that what? It is actually what? X. So x raised to power of nothing cannot give you x back. It can only give you what? 1. So that is what we have under the laws of indices. So I want you to go through these laws, get yourself familiarized with the laws. I'm going to be applying these laws in the next class, and then we'll be checking out past questions on indices for you to get yourself prepared in your examination, so that anything related to indices, you know that you are good to go. Thank you very much for paying attention in today's class. If you do enjoy today's class and you find this video helpful, please kindly share it around you with students that may be preparing for examination, or students that may be trying to groom themselves in mathematics, so that they can actually get familiarized with these laws of indices, and then you can check the next video for you to mount on the knowledge that you have gained in this class. My name is Mr. Legend. Subscribe to our channels and do turn on the notification button, so that anytime I drop a new video, you can get alerted. Thank you very much for today's class. Bye for now.